know for sure, what's this particular sugary cereal gonna do? But then, you go 80, 100 years and get some experience, and maybe now we wouldn't even try to do that test. So what I'm saying is, if you look at that going, why would we even set that as a null hypothesis? At some point in time, not too long ago, we didn't know. And so we had to act as if the other was the outstanding claim, that the sweetened cereals, the sugary cereals, would increase the mean number of cavities. So if I make, well, here, increase makes me think of greater than 0. Which group am I calling population 1 then?
Eat the sugary cereals?
The ones that are getting to eat the sugary cereals or sweetened cereals. Okay. One-sided or two-sided?
Uno. One-sided.
One-sided. Remember, what you say here, I'm not so much watching for, it's what you do later. Are you looking in the right spot on the percentages at the bottom? Or in a one-sided test, as you remind me, a two-sided test, if you do normal CDF or TCDF on the calculator, multiply by 2. Here I would not be multiplying by 2 if I go that route. Okay, what else do we know? We're going to need, according to the formula right here, you can't quite see it when I do it that way. There. All that's saying is difference in sample means over standard error, which is not much different than what we've been doing before. It's just calculating standard error is a bit messier now. Since we said let's call this population 1, then population 1, let's see here, actually matches with what we have here, group 1 that eats this sweetened cereals regularly. X bar is 341, x1 bar minus x2 bar. 3.41 minus 2.73. No. 0.68, is that right? Sure. No, I'm not trusting myself here. Caffeine's wearing off. Yes? Yes? Anybody else confirming? 0.68? Okay. All right. And as for our standard error, remember only the numerators of the fractions are getting squared. Your standard deviations from the samples, that's what's squared here. Now let's say you get group 1 and group 2 reversed. There's a sort of symmetry to this formula where in the second part here, it's not going to matter. And it also shouldn't affect too much of the rest of it. It's just if you get a negative t-score, I'd get a positive t-score or vice versa. Okay, what do we have here? What's S1, S2, N1, and N2? 1.28 squared over what? 62. 62. That will get added to, all right, somebody else. What am I squaring in the second one?
1.17.
1.17, and that'll be divided by 167. Sample size there. Okay, I forgot to open up my calculator on there. So tell me everything the calculator's giving.
The answer to it?
Uh-huh.
3.6544.
This part.
Oh, my bad.
for the standard error. I'm expecting something pretty small.
0.18607206224.
Is anybody else getting the same? That's in the range of what I would expect, because we're squaring small things, dividing by fairly big things, etc. So, Abel, you're backing it up. Anybody else backing it up? Okay, 2 more. Okay. All right, so let's divide. That's our numerator. Let me see if I can keep it on this side of the board. So T, the x1 bar over our standard error, x1 bar minus x2 bar, that is. It's going to be the 0.68 divided by this messy thing. And once you've done that division, that's when it would be appropriate to round T to 3 places. You were saying 3 point something. What did you get to 3 places?
It's 3.654.
Okay, what was after the 4?
Another 4.
Okay. Now, the reason why sometimes I say round to 3 places or to 4 places is, believe it or not, sometimes if I say to the hundreds, how many places after the decimal point is the hundreds place? 2. And yet either people aren't looking at the direction, or there must be enough people, and I don't just mean this class, I mean lots of classes lately. Either they're not reading the directions, or they don't know what the hundreds place is. So that's why on the last homework I said round to 4 places. I meant 4 places after the decimal point, i.e. to the 10,000ths place. Okay, anybody else back this up? What do we need to do before we look up stuff in table C? What do we need to know?
Margin of error? No?
Not margin of error, that would be for confidence interval.
Yeah, degrees.
Degrees of freedom. How many are there?
61.
Anybody back that up?
My second motion.
2 for 61. 3, 4? Dakota, what is he doing to come up with 61?
He's taking the samples, the minimum, both the samples, minus 1.
Actually, that would work, because if you subtract 1 first and then take the minimum, you'd get the same thing every time. Okay, did everybody catch that? Subtract 1 from each sample size. Take the smaller of the 2. All right. This came up on the exam as well. I don't think there's anything in table C for 61 degrees of freedom exactly. So once I bring this up, I thought I had left this open, but apparently not. Oh. Yeah. Table C. Here we go. Table C. Yeah, 61's not on there, so what do you do?
Yeah.
Go to 60. Because whatever 61 would give you, 3.654. It's actually bigger than 3.460, the biggest in the row. Well, whatever you would have for 61 degrees of freedom would be somewhere in between these 2. And so if you go up a row, that's a smaller sample, smaller degrees of freedom, bigger T stars, being more conservative. If we had talked about margin of errors for a
I
confidence
just called it
interval.
wrong, I knew what we were looking for.
Okay,
I didn't.
but it's worth bringing it up now. If we were doing a confidence interval, it would give you a bigger margin of error, wider confidence interval, so that you've got a better chance of capturing mu. Similarly here, we don't want to reject H0 too quickly. So we're going to 60. And that value for t is already bigger than the biggest thing in that row. We've got 3.654 greater than 3.460. What's that tell us about a probability then? A one-sided p. I think you're showing something in the air. What are you trying to describe?
No, I was just wondering where you wrote it on the board.
Part that I've almost boxed off. So I'm also trying to make it clear for the camera. So the fact that 3.654 is greater than everything in that row, what's that tell us about a one-sided p?
Fail.
Don't answer that yet.
Smaller. Smaller.
Don't answer that yet. If we use the calculator with TCDF, we can say what p is equal to, or nearly equal to. Here we have an inequality. How does p compare, when I went down from that value, t, how does it compare to 0.0005 from the one-sided p row? Okay. Yep. P should go along with this. 3.460 trace down to that, so it is less than. It switches the direction of the inequality. That's less than alpha. That's not 5%, it's 0.05%. Now think it through. Some stuff some people wrote on the test, which, well, it's the first time you had a full-blown test on this material. And if you got marked wrong there for what conclusion to draw, let's try to fix that. Think of the logic here. That 3.654, not only is it way bigger than anything in that row, that means that it's pretty extreme.
So why are you saying it's less than the 0.005? Why did you change the sign?
Because as we go to the left to right here, with T stars for any degrees of freedom, or for Z star, what's happening at the same time to the one-sided P's and the two-sided P's?
They're getting smaller.
They're getting smaller, which leads me back to this point. To have such a small probability, you had to have something pretty extreme. I'm putting this on the right because it's positive, bigger than 0, after the standardizing. So maybe we're way out here in a tail. That's extreme, unique. It's like Sheldon Cooper claiming that for those of you that watch The Big Bang Theory, I have an IQ that's not even measurable by standard IQ tests. He's talking about having an IQ of more than 180. Would you, well, when something's that extreme, what's the likelihood that there's no difference between the two cereals and whether they have a difference in the cavities they cause? When it's extreme. Do you believe this? Or do you believe this? It's like the eye doctor. Do you believe this? Believe this? Switch the lenses back and forth. This. It's extreme. Which one should you probably be going with? Which one? Okay, so we would say reject H naught. When P is less than or equal to alpha, that's because you have something extreme, very unlikely. That's when you would reject H naught. And if you have to put it in the other phrasing, you have significant evidence that these sugary cereals or sweetened cereals do increase cavities.
Reject H.
Nope, H naught. H naught is being rejected, which would point me in the direction of saying, well then HA, I've got significant evidence for it. Alright, so this is something we've said a few times now. Real quick then. Something like that may only be out of, say, a 15-point question. It might only be one or two of the points making that decision at the end. Really, that's just to make the scoring easier for me. In terms of the importance, maybe I should do something like make it worth 4 of the points, in case some of you are using this later. But I'm trying to make something that's quick and easy to apply and consistent. So, if you're one of those people that's had it reversed on the final, on the exam 3, every time I said fail to reject H naught, you said reject H naught. Take a look at that, look into the logic in the book. Look into, say, some YouTube videos that try to explain it, or some websites that just explain it in text. Okay? Good luck. I'll see you Monday. What time?
1 o'clock.
Alrighty. That's great. I think maybe I missed
Blaze and glory all together.
I asked Matt
Yes,
about
I
these.
missed Bobby.
Are we?
186.
I have the last.
See, that's almost,
I got 18
That's
out of 20,
almost-
you got 18 out of 13, you got
That's
20 out of 13, you copied my
almost-
paper word for word.
so getting a 3 point something.
I know. You copied
I
my
just
paper.
copied it, what it was. Question?
Do you understand that? I did.
60? Because again, 61's not on there. Oh, I didn't pick that. Here, let me bring the screen back here. It wasn't a choice. It was based on, if you understand why we're using 60 degrees of freedom, we're trying to compare the T that we got to one of these T stars, either to put it in between two of them right next to each other, or else it's bigger than this, or smaller than this. And by the way, if you put in TCDF, this is bigger, so shade to the right, 10 to the 99. Have you tried using normal CDF and TCDF before? Okay. Do you remember what the last thing you need is for TCDF? Actually, we can go to 61 on this one. Okay. You should similarly get something very small. What we're doing then, I didn't choose that column. It's because my T came out bigger than this T star. Trace down to the one-sided P with that T star, and since that would match up exactly with P equals 0.0005, a more extreme value of T, like that one, should have even less of a probability.
So 0.005 was probability?
Yep.
And since it was less than, you rejected it?
Since that is less than our alpha, our probability is less than this is less than our alpha, that's why we're rejecting yes. Alright. Holly, did you have any questions?
Yeah, I have just a real quick question. To find the correlation R, is it somewhere in the calculator or is there an actual equation?
There is a formula, but we didn't cover it. It's in the book in chapter 5, I think it is, either 4 or 5. But yes, you can get it from the calculator.
Okay, can you show me real quick?
Do you have some data in there right now?
Yeah, I have. It's the same problem that I had trouble with.
Okay.
It's all in there. So.
Okay. And calc is the fourth option. Tell it the x's are in list 1, comma, y's in list 2. And if you also wanted to graph, one more comma, bars, y bars, press enter a few times, it'll put y1 there. It saves the equation. If you press y equals in a minute, it'll save the equation, and when you regraph it, it'll have the line in the scatter plot. The r is right there. Okay? Not r squared, but r is the bottom. And here's the graph with the line along with it too. YouTube videos will remind you of that stuff if you forget before next Tuesday.
And wasn't r squared something?
It stands for the percent, well, if you convert your decimal to a percent, how much of the variation is being explained.
Okay.
How much of the variation that we see in y is explained by the variation in x.
Will that be asked on the test, do you think?
If you see one like that on the sample final, then most likely yes.
Okay.
Okay?
Thank you.